Hello everyone. Today our topic is photochemical halogenation of alkane. This is an important reaction in grade 11-12 organic chemistry. So let's start photochemical halogenation. So by the term photochemical means a chemical reaction which is taking place in the presence of photons. Photon is basically a bundle of light energy. So a chemical reaction in the presence of sunlight is known as a photochemical reaction. And in this reaction, homolytic cleavage of a covalent bond takes place, which results in the formation of free radical as an reaction intermediate. Species having unpaired electron. So this one is an unpaired electron. Species having unpaired electrons in organic chemistry are known as a free radical. So next is halogenation. Halogenation is basically to insert halogen in place of hydrogen, which result in the formation of a compound Rx. IUPAC name of this compound Rx is haloalkane and its common name is alkyl halide. So halogen in IUPAC name it is not we use the term halo here, and in common name for halogen we use a halide. The various halogens are fluorine, chlorine, bromine, iodine. And if you call these as halo, so ion is replaced by O here. If you just check chlorine, chloro, bromine, bromo, iodine, iodo. Ion is replaced by O here. And in case of halide, this INE is replaced by ide, like fluoride, chlorine, chloride, bromine, bromide, iodine, iodide. The order of reactivity of halogens for photochemical halogenation reaction is fluorine is most reactive in nature, whereas iodine is least reactive here. Because of the most electronegative nature of the fluorine, a very fast reaction takes place, or you can say a drastic, vigorous reaction takes place, which result in extensive rupturing of CC and CH bond, and sometimes it catches fire. Whereas if we just talk about the iodination reaction, in this case, a slow reaction takes place, which is of reversible nature. Hence, direct fluorination or direct iodination are not favorable. In case of chlorine and bromine, chlorine is more reactive, so its selectivity will be less, whereas bromine it is less reactive, so it is more selective in nature. The main component of a reaction is alkane. Alkane is basically a combination of alk plus ane. Alk is a carbon chain part, whereas a ane means a single covalent bond between the carbon and carbon. This single covalent bond is a sigma bond which arises because of an extensive overlapping between the orbital. That's why its bond strength is quite high. So because of high bond strength, a large amount of energy is required to cleave this bond. So alkanes under normal conditions of temperature and pressure, they are quite inert, or you can say have little reactivity. Alkanes show a chemical reaction in the presence of sunlight or at certain elevated temperature like 520 to 570 Kelvin. So to understand this part, let's take a simple example of, suppose we have this compound, we add bromine to it in the absence of light. So in that case, no photochemical reaction takes place. And if the same reaction takes place in the presence of light, then this compound undergoes a photochemical halogenation reaction. So, photochemical halogenation of alkane is a substitution reaction where we insert halogen in place of hydrogen, and the byproduct of the reaction is HX. This reaction follows free radical mechanism And the three steps of the mechanism are initiation, very first step, second step is propagation, and the last step is the termination. Hydrogen abstraction sequence is benzylic allylic, most, then the tertiary, and the least one is the primary. Like suppose we take an example 1, and when we do the photochemical halogenation of this compound, then the major product is obtained by abstraction of benzylic hydrogen. So in this case, major product is obtained by abstraction of this benzylic hydrogen. Let's take another example. These are allylic carbons. These two are allylic carbons. And the hydrogen belonging to these allylic carbons are allylic hydrogen. So this compound on photochemical halogenation abstract this allylic hydrogen. Switch to next example. Example 3. This position is again an allylic position, and on photochemical halogenation this compound abstract allylic hydrogen. Example 4, we have tertiary carbon and primary carbons. So in this case, the major product is obtained by abstraction of tertiary hydrogen here.